Alright, so this video is going to be part 2 of integral problems with parametric equations. Alright, we have our problem up on the board here. We need to find the area enclosed by x equals t squared minus 2t, y equals the square root of t, and the y-axis. Okay, and we have our substitution rule up here, right? This is how we integrate parametric equations, alright? So, we need to find f prime of t, alright? That's kind of the first order of business here. Now, as I said in the last video, okay, if you missed that, definitely go check it out. X is equal to f of t, y is equal to g of t. Okay, that's how we're using this, right? So f prime of t is going to be the derivative of this x equation here, which is 2t minus 2. And g of t, okay, we're not taking a derivative here, that's just going to be rad t. Alright, so now we have our integrand, but we still need to find our bounds. Okay, so we found this and this. We need to find our bounds, alpha and beta now. So how do we find that? Well, we know that this curve is going to touch the y-axis, right? It's probably going to touch it, it's most likely going to touch it in just 2 spots. It might touch it in more, in which case we would have to probably separate this, but you're not going to get anything like that. Anyways, what is the significance of the y-axis? Well, that's where x equals 0. Okay, so we can just set this equation equal to 0, right? So 0 equals t squared minus 2t. Okay, we factor out a t here. We get 0 is equal to t times t minus 2. So t is equal to 0 and t is equal to 2. Okay, those are going to be our bounds. Alright, so now we can just plug into this integral right here. We get the integral from 0 to 2, f prime of t, that's 2t minus 2, times g of t, which is rad t. We can rewrite that as t to the 1/2, so it'll be easier to distribute this to the 2t minus 2. Alright, and of course we have our dt on the end. Let's distribute that t to the 1/2. We get 2t to the 3/2 minus 2t to the 1/2 dt. Alright, we can take that 2 out, because why not? We get 2, the integral from 0 to 2 of t to the 3/2 minus t to the 1/2 dt. And now, let's integrate. So we get 2 times, this will be 2 over 5, t to the 5/2 minus, we're going to add 1 here, bring it up front, flip it, we get 2/3 t to the 3/2. That's going to be evaluated from 0 to 2. You can probably tell 0 is just going to kill off everything, so we don't even need to worry about that part, but we can plug in that 2. When we plug in that 2, we'll get 2 over 5 times 2 to the 5/2, and then we'll get minus a 2/3 2 to the 3/2. Alright, now we can simplify this. Okay, we definitely don't want to leave it like this. Okay, so a 2 to the 5/2, right? I'm going to split that up into 2 to the 4 over 2 and 2 to the 1/2. Alright, then we can kind of see that this will be a little bit easier to simplify. So we'll get 2 times 2/5, as I said, 2 to the 4/2, which we know to be 2 to the 2 squared, I guess you could say, and 2 to the 1/2 minus 2/3. All right, we know that's 2 rad 2 because it's 2 to the 2 over 2 times 2 to the 1/2. All right, and then we're going to bring that up here. We get 2 times 2 over 5. This will be 4. All right, so this actually, we can rewrite that as 8 over 5. And we're going to have a rad 2 here. Okay, and then minus, we have a 2/3 times 2. It's going to be minus 4/3 instead. And then we have a rad 2. So we have minus 4 rad 2 over 3. All right, let's factor out a 4 here, and then we should be done. We get 8 times 2 rad 2 over 5 minus rad 2 over 3. All right, and that is your answer. All right, so nothing too bad here, okay? Really, the hardest part is just remembering this formula. That's really it. All right, and it's a pretty easy application. You might have a little bit trouble finding your bounds, but if you just remember, well, the y-axis is where x equals 0. You set it equal to 0. You find your t's, and then that's your bounds. So really, it's all fairly straightforward. All right, so that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for parametric integrals, and the next video in the series. See you soon.